Hi guys, welcome back to my online mathematics tutoring. And in this video, we want to look at the properties of derivatives, part 3. And in the last part, we discussed the quotient rule. So we want to look at now the product rule. In the next video, we will do the chain rule. So the product rule is just like saying you have one function being multiplied by another function. How do you then find the derivative of that function now that is written in terms of one function, but it is a product of two functions? You didn't get me. Let's get started. So let's say let's make some indication. Let f of x and g of x be differentiable function, or we say be differentiable. That is to say, functions that can be differentiated. So when f of x and g of x, in some books you will see let u and let v be differentiable functions. So whatever the case might be. So now if we have y now to be a function involving f of x and g of x, but it's like product, one function multiplied by another function. Assuming that this f of x function could be a linear function, this function could be a quadratic function, in two terms or in one term or in three terms, in whatsoever form. Assuming that this first function could also be a linear function like x plus 1 times this one could also be a linear function x minus 2. But these two are two distinct functions. So if you have a function multiplied by another function, how do you then find the product, the derivative of the product of that function? So the rule says, and if you check previous video that we derived using the first principle of derivative, you will see how it was easily derived. So the rule says y prime would just be equal to f of x times g prime of x. That is, you holding f of x function constant and you differentiating g of x function. Then you write a plus sign. Then, because the first time we differentiated g of x, so in this form now we are holding on to g of x and differentiating f of x. So whenever you don't see this stroke, which we call the prime, it means that function was not differentiated. So this is it. This is it. This is the rule, the product rule. Or if it was in u and v, it means that if you have u times v, the derivative, now we can also say dy by, now let's be careful, right? Let's maintain y so that it doesn't get you confused in terms of u and v. So let's maintain y, because if it was in this form, we could just use dy by dx. That is the derivative of the function that you are differentiating, that is called y, with respect to the variable within that function, which we call x. So let's maintain y. So now we have y prime equals. So again, we hold the u, the first function, times, then we differentiate v, we get v prime. Plus, we hold v now, and we differentiate u, we get u prime. So this is just the same as the previous one we did. So let's look at some of the examples. Example number 1. Find the derivative of y equals x times x plus 1. Hey, okay, so I'll put x squared. Now, somebody may say, but why is it I can just multiply this times this x times this x squared, then x times 1, so that I cannot give myself headache with this or product rule? Because in this problem, you see one factor and another factor, right? So this is in a product form. So y prime now, remember the rule, we're following the rule. We say hold one function. In fact, it doesn't only have to be the first function. It could be the second function, it could be the first function, but hold one and you differentiate the other. So we're holding this x, and we're differentiating x squared plus 1. So we say times. So say we want to differentiate this one, we say let's use the derivative notation, d by dx. This is a notation of x squared plus 1. Then we say plus. Now the first time we differentiated this, which is this one. So now let's hold on to this x squared plus 1. And then we differentiate x. So we say d by dx of what we are about to differentiate, which is x. So if there is a long process, you don't have to follow this step. You just have to escape this step and move to the next one. So now we have y prime to just be equal to, this is x, so we hold this x. This is what we're differentiating. The derivative of x squared, you bring the 1 down, remember, 2x, then you subtract 1 from here, which is just 1, right? And we told you the derivative of a number, a constant, is equal to 0. So this one will just be equal to 0. Plus, we rewrite this x squared plus 1, and we differentiate x. So the derivative of this x, now mind you, x is raised to the power 1. So if you bring this 1 down, 1, then you subtract 1 from here, you will notice that you have x to the power 0. And anything raised to the power 0 is just equal to 1. So the derivative of x will just be 1. The derivative of 2x will just be 2. The derivative of negative 3x will just be negative 3, and so forth. So this would now be times 1. So we can now multiply x times 2x will now give us 2x squared. And then x times 0, you know that literally will just be 0. 1 times x squared will give us x squared. And then 1 times 1 will give us 1. So y prime. So we have 2x squared plus 1x squared. So it just equals to 3x squared plus 1. Now, someone is saying to themselves, but why is it that I could not just multiply x by x squared and x by 1? What if your teacher gave you this problem? Question 2. Y equals x times, okay, so I just use x plus 1 times x plus 5 raised to the power 98. So what if you